So in this next video, let's start by, for the first time, creating a C programming project within our relevant IDE, Atmel Studio. So first, let me actually switch to my Atmel Studio window. And let's imagine we just opened up Atmel Studio. And just as before with assembler projects, when we create a C program project, we're going to go File, New, Project, click on that. And then before we would utilize this assembler tab and go AVR assembler project and go from there. But now we're going to go to C, C++, and we're going to click on GCC, C executable project. And we're going to make sure that we do not click on any other option, specifically C static library project or anything related to C++. We're going to make sure that we do GCC, C executable project. And just as before, we're going to click on make sure we have a relevant location. And mine's going to be, for this series of videos, a folder called Atmel Studio under my desktop. And let's say for this series of videos, let's call this C Programming Basics. And sure, I'll create a directory for my solution, hit OK. And just as before, let's specify the relevant device, our microcontroller, hit OK. And we see solutions created, project window comes up. And we see some similarities and some differences. Maybe most notably, we see within our code editor window this strange looking code that we can probably deduce is C code. Now, we're not going to really touch much on C code at all in this video yet, but we first, for the remainder of this video, just want to set up a couple more things about a project solution that we'll have to do. And since I don't have a better place probably in this series of videos to do it right now. So in general, just as with assembler projects, there's generally the need or motivating need or want to have multiple files and multiple programs all under the hood of one project. Like, let's say again, for the motivating example of, we have a lab assignment that has multiple programs that we have to create. Rather than create multiple projects, we create multiple program files. So just as before with creating multiple ASM files, let's say we want to create multiple C files, which we can probably deduce our programs are going to be in C files. So what we do, just as before, we're going to right click and add a C file. And generally we do that by going to Add, New Item, if we want it to automatically be added to the project solution. And you would usually see assembler file, assembly file, include file, and with assembler projects, but now we see a few more options. We're going to go ahead though, and for the purposes of, let's say we want to create another program, those are going to generally exist within C files. We'll go ahead and for this purpose, create such a C file, call it test, and hit add. And just as before, it pops up this new file that was just created. And within C projects, we can see that all was created was a header. But let me go ahead and type the following and then explain it in a second, because it will be pertinent. So basically, just as before in assembler projects, the main distinguishing factor between multiple programs was multiple routines that were to be used as entry points when we started executing some code in our processor. So usually we had those routines that were such entry points called main, and that in default or in general is a typical conventional name for such primary routines. Now in C, main is also a typical name for entry points or routines that have that entry point. And instead of those being just represented by a label in assembly, we're going to see them represented by what's known as a function. And I'll highlight this is the overall function called main. And in Atmel Studio, and most tools for that matter, main is the typical default name that we're going to need to utilize for the tool to recognize, hey, this is the program that this user wants to set as their entry point. Now you can see probably though that the problem would arise if we have multiple files that maybe have the same name for some routine. In this case, they're called functions. We'll talk more about that later, but functions, they have the same name. Now if we have these two files that have the same name for some routine, the compiler, which is another tool that we've talked about thus far in another video, the compiler is going to actually throw an error for this. Let's actually see if I build the project. It'll throw me an error saying multiple definition of main. That's telling me, hey, this name's been declared or defined twice. Now I don't know which one to specify, so tell me which one, or it's letting me know, hey, there's a problem, guy. So in this case, what I want to do is, just like before, specify which files I want to build. Now, different than assembler projects, before what I would do for some assembly file that I wanted to specify as the main file to build, I would right click and there would be some option like set as entry file. Now, I don't have that option here for a C file. What I actually have to do is a more roundabout way, is I actually have to specify which files I do not want to be built. Now, there's some benefits of that, but it's neither here nor there. We just have to deal with it with Atmel Studio. So let's say, for instance, I do not want to build my main, this file named main. I want to instead build this file named test. So what I can do is I can right click and I will go to the properties window instead. And I already have it up, but if you didn't have it up and you went to properties, this properties tab will pop open, and the main item that you want to look at under this properties tab to do what we're talking about right now is build action. And compile is telling us by default this file is going to be compiled in the overall build of our project whenever I hit build. Now, compile, again, we can probably deduce it has something to do with this tool called the compiler, and in fact does. And what we basically want to specify is to the compiler, hey, don't compile this file. So what we do is we go ahead and hit this item, hit this drop down, hit none. And this will say, and it also shows me visually, hey, this guy's not going to be built anymore, or compiled, included in the build process. And if I were to go ahead and build again, we'd actually see our error go away, and now build has succeeded. And now what happened is this test file was considered as, it's basically going to use this main routine as my main entry point. And we're going to talk more about that later, don't worry. But nonetheless, I wanted to show how we would actually go about creating multiple program files or multiple entry points for when we're programming with C, because I'm going to need that for this series of videos, and you all will for your lab assignments assuredly. The only other time that you would want to do this for programs is if you have some other file, again, that has, say, similar named items that the compiler will, again, throw similar errors for a multiple definition of these two substances, whatever. So besides that, there's only one other thing I want to show in this setting up video. We're going to talk more about various stuff within setting up Atmel Studio probably throughout these series of videos. But the main thing, again, for lack of a better place, I want to show us how to turn off or change settings regarding to the optimizer of the compiler. And I'm going to talk a couple details about that in a second, but I want to first show us how to actually get to where I want us to go. So first you want to go to project, and then with your solution name properties, click on that. And then under the second section here, avr-gcc compiler, we're going to want to go to the optimization tab. And under optimization, whenever you guys create a project, we're going to require that you all, for this course, whenever creating C programs, go to optimization level, hit this drop down, and instead of optimize-01 by default, we're going to click on none or -00. And basically, what this is ultimately doing, there is a portion of the compiler within our tool chain that optimizes our C code. And by default, there's some optimization to try to make the C code more efficient or more appropriate in terms of assembly code. And there's some other options we can see as well. If I drop this down, there's different criteria that the optimizer could optimize for, such as optimize for size, which will ultimately try to minimize program code size, optimize debugging experience, and others, etc. But for our course, we want you to select none, because in general, for this course, there's going to be a few opportune moments where we want to show how a compiler doesn't always generate as correct or as efficient assembly code that we want in terms of maybe functionality or, again, efficiency. So to kind of enforce or make sure that that happens in this introductory course for trying to apply C programming to microcontrollers, we want to highlight those moments and show us how, if we didn't have a compiler to optimize our code, and even sometimes with optimization, the same issues will happen. We need to have clever strategies or more clever manners for implementing some code sometimes. So to do so, again, in general, we want you to turn off the optimization level. We want you to go, again, project, properties, avr-gcc compiler, optimization, and turn it off here. Then we can go ahead and save, and then nothing else changes beyond that. We just build and everything stays hunky-dory. And we're going to talk more about the optimization levels soon and see how those actually apply in different various capacities throughout the remainder of these videos. But for this video, that's all I really wanted to talk about. In the next video, let's go ahead and start getting our feet wet with a introductory C program and basically translate some things that we might have already done in assembly over to C, and then see how the compiler generates some assembler code or assembly code for that relevant program. So let's go ahead and get started.